Hey, eighth grade, this little video to help you with your homework. Now, I did say you could use technology, so I would really recommend using GeoGebra for this one because that's what I'm going to describe how to use in this video. Okay, so let's take our first problem here. Erica jumped off a cliff into the ocean in Acapulco while vacationing with some friends. Her height as a function of time could be modeled by the function h of t equals negative 16t squared plus 16t plus 96. Okay, so we've got a quadratic function here. And what we're going to do is we're just going to type that in to our GeoGebra. Now, what I would recommend doing, first of all, go to GeoGebra, make sure algebra and the input bar are turned on. The input bar is this thing at the bottom, and it lets us type in there. So we're going to say h equals negative 16. We're not going to say t. We're going to use the variable x. That's how we graph in GeoGebra. To do the second power, you have to hit Shift 6 to get that caret symbol. And then now you put the exponent. The exponent is 2. Plus 16x plus 96. Okay, there's our graph. Now, obviously, this is not the way it should be. I mean, I can't really tell a whole lot here because the x-axis is so spread out. So what you do is take the select tool, click on the graph, click on the this button over here, this little menu, go to the gear, and that will let us go to basic, and that'll let us change the dimensions of our graph. Now, our x minimum, we don't need our x-axis to go into the negative, so I'll just do -1 just so we can see the y-axis over here. And then our x maximum, obviously, this could be less than 10, so I'm just going to go like to 8. Okay, now there's our graph. That's a much better looking graph, and I'll even drag it out here a little bit. And that's our graph. So we're going to use this graph here to answer the questions that are asked. Number 1 says, how long did it take Erica to reach her maximum height? Okay. GeoGebra actually has a button for this. So after you've graphed your function here, make sure you've typed it in correctly. If you go to the point tool and you go to this little tool here called extremum, this will find the minimums or the maximums of whatever function it is you click. So this function here is a decreasing function. It's a parabola that opens downward. So it has a maximum. And if you click on the function while you have this button selected, it'll tell you that the maximum is this point right here. And that is the vertex of our parabola. It has coordinates 0.5 and 100. Okay, what does that mean? Well, remember that our x variable is time in seconds, and our y variable is her height in feet. So this means after 0.5 seconds have passed, she'll be 100 feet in the air, and that's the maximum. That's as high as she gets. So let's see, to answer the question, how long did it take? That would be half a second. What was the highest point that Erica reached? Well, that's exactly what we just found. It'd be 100 feet up in the air. So both questions are answered right there with just that one point. After how many seconds did Erica hit the water? Okay, well, it certainly looks like 3, doesn't it? I mean, this is where the graph crosses the x-axis, it looks like. But the way you can do this for sure is to do this. You grab your intersection tool, and you click on the graph, and then you click on the x-axis, and it'll put intersections. It'll say, oh, well, the graph crosses the x-axis at these 2 points. And let's look at them. The point that we're concerned with is the point C. And it looks to me that the graph crosses the x-axis at 3. What does that mean? It means that she jumps here, goes up a little bit, and after 3 seconds time, hits the water. Okay? So that's how you can use GeoGebra to answer these questions. I use the intersection tool there. Let's take a look. Let's see if one more. Okay, I'm going to do this next one here, and that's it. And then I'll let you guys just kind of go to it. So I'm going to erase all this stuff. I could have just deleted this. Okay, so I'm going to type in my new function. Now, my new function says here that you're trying to dunk a basketball. You need to jump 2.5 feet in the air to dunk the basketball. The height that your feet are above ground is given by the function h of t equals -16t squared plus 12t. That's it. There's no constant. So again, I go down here. I'll say y equals, or you can call it whatever you want. So let's say g equals negative 16x, shift 6 to get the caret, hit the 2 for the exponent, plus 12x. Oh, wow. Okay, so here's our little jump, not very high off the ground. I think we should probably zoom in a bit. Okay. So I'm just going to put a point on this, and I'm going to go ahead and okay. Now this point says that start at 0, 0. I'm on the ground. I jump. This person jumps. After 0.2 seconds, they're 1.75 feet off the ground. They get somewhere around there to their tallest point. They pass their tallest point. They keep going down. All right. So this is an accurate parabola. It's just that this person really didn't jump very high. Okay. So let's delete that. We're going to go back to our extremum tool. I click on the parabola, and it tells me that this person reaches a maximum height of 2.25 feet after 0.38 seconds. Okay, so what is the maximum height of your feet above the ground? I just said it, 2.25. Will you be able to dunk the basketball? It says you need to jump 2.5 feet, so that's not enough. You get close, okay, but no cigar. All right, so this is how you use the technology. Mainly, you're going to be typing things in the input bar, like I did here. Make sure that you use the Shift 6 to do exponents. And the extremum tool, and there's also the roots tool. And if you click on the function, it'll just tell you where the graph crosses the x-axis. You can also do that intersect thing that I did. Watch, if I click the parabola and I click the x-axis, it puts 2 points exactly where the other ones were. Okay, you can see 0, 0, 0.750. So basically this tool, the roots tool and the extremum tool, that's all you really need to answer any of these questions. That and an understanding of how graphs are interpreted. Okay, that's it. So if you have any questions, you can send them in the comments. Oh, right. All right. So let me show you one other thing. Now, once you do this, you have to submit a picture and attach it to your work. So I'm going to show you how to do that. So what you're going to use is the snipping tool. Everybody has this. If you have a Windows PC, you've got a snipping tool. I'm sure Macs have one as well. If you have Windows 10, there's a keyboard shortcut. It's Shift Windows key S, and it opens up a snip. All right, here's what you're going to do. You're going to select your parabola. You're going to show me at least the vertex and the two roots. And then what you can do is you go over to your drive, set up a new Google Doc called Projectile Motion, open that up, type number 1. Actually, this is number 2, so I'll do number 2. Control V. There's my picture. And then I'll answer the questions. Number 1, nope, no dunk, 2.25 feet max. Now, obviously, I won't accept answers like that from you because you need to give your answers in complete sentences. But that's the idea. So there we go. And then you'll go on to the next question, whatever, and then you'll do your next picture and answer the next question. Then when you're all done, you go to your classroom page, click on the assignment, the projectile motion worksheet, go to view assignment. Oops, I'm signed in as myself. Let me just sign out real quick. Okay, so I'll show you the student interface. So here we go. You're going here. You go to your classwork. You go to projectile motion worksheet, view assignment, add or create, and then you can just hit Google Drive. And I'm going to click my projectile motion that I just made. And once you're all done, you do this and you hit add, and it will attach that document. And I'll be able to see it and grade it and turn it back to you. Okay, so that's how I want you to do this one. All right, if you have any questions, let me know. Also, you have until Wednesday to get this done. So if you have any questions, you can find me tomorrow and ask them. Okay, good luck. Bye.